Hey everybody, welcome back to another round of engineering. And yeah, let's go ahead and run some more example problems using the mesh current method. So I've got another circuit diagram in front of you, and this may look familiar because we actually analyzed this using the node voltage method. So I thought that it might be nice just to go through and see for a couple of different examples that, yeah, you end up with the same stuff through a different method. So go ahead, take a minute, see if you can hack through this one. You got it? It's good. Okay, so let's go ahead and we need to think about what do we need to do. So first of all, the question is how many meshes do we need? Meshes. And we see that and we have, well, first of all, usually I think of going counter or clockwise. I'm going to do this one counterclockwise. So we have 1, 2, 3, and 4. And hopefully you see why I decided to go counterclockwise is because this 4 amp source at the end here is going counterclockwise. So I'm just choosing that to make my life easy. The other thing is that we notice we have a dependent voltage supply, a current controlled voltage supply, which depends on I phi, and I phi is going to the left. And so that matches with that counterclockwise that I chose. So there's two reasons why I went counterclockwise here. So we're off and rolling like a bale of turtles. We go ahead now and we apply our Kirchhoff's voltage law coupled with Ohm's law and write down equations for our 4 meshes. So starting with the top, and I know you probably already have this down, but we'll go through anyway. If I walk around counterclockwise, the first thing I have is a drop across this 40 ohm resistor. So I do negative 40 I1 minus I2. Keep walking around, and I have another drop across my potential supply. And then I'm back at my starting point. Okay, well, we go to 2. Okay, and we walk around, and I'll start here and go counterclockwise again. And we have a drop across the 50 ohm resistor. Bearing in mind our convention of writing the mesh that we're in minus the current in the mesh that we're sharing with. Okay. And we get up here and we realize we don't have a shared side. So we have a drop, but now we only involve a single current, I2. Keep going. We have our 40 ohm resistor. And again, I2 minus I1 equals 0. Number 3. Okay, well, start right here and go. We have a drop across the 100 ohm resistor. I3 minus I4. Keep walking. Okay, we have a drop across this potential supply. And here we need to take advantage of the relationship between the potential supply and the current. So the drop across this supply is 10 times what I have called I2. So we'll go ahead and use that dependency when I write down this, or in this Kirchhoff's voltage law. So I'm going to go ahead and write 10I2 here. We keep going, and we still have the 50 ohm resistor that we have to take care of. And we're back at our starting spot. The advantage for the 4th loop is that because it contains this current supply and it's not on a shared edge, we can immediately write that I4 must be equal to, excuse me, that little thing got in there, I4 is equal to 4 amps. Now we have our system of equations. We can now determine the current in each of those meshes. So go ahead. We hook up our 4x4 matrix. Okay. Here we go. I'll go ahead and write down the augmented matrix. I'll use the first column for I1, the second column for I2, third column for I3. Okay. And I have something like negative 40 plus 40 and 0 gives us 50. That's from the first equation. Second equation, okay, well, I have a positive 40 I1, so let's put the 40 in here. That takes care of that guy. Then I have negative 50 minus 5, so 55, 40. So I have negative 95 here. And lastly, double negative gives me a 50 I3 and 0. Okay. Last one. Okay. Well, there are no I1s in our third equation, so I'll put a 0 here. We have I2s. We have a negative 10 I2, negative, negative. So we have plus 50. So this will give us 40 I2. And then for I3, we have negative 100, negative 150. On the other side, we have I4, which we know to be 4 amps. So this is 100 times 4, so that's 400. And then we move it to the other side of the equation for standard form. So we should get something like negative 400 here. There is my augmented matrix for the problem. Okay. Now, at the end of the day, so we go through and we solve this by your favorite calculator means. And I have I1, I2, I3 is equal to, I have 0.75, so 3/4. I have 2 and 3.2. These, of course, are all in amps. So I'll put my unit, I'm running out of space there, but I'll put amps there. So now we have identified the mesh currents. The last step for us is to combine the mesh currents to find the currents running through the shared branches. Okay? And when we do that, hopefully we'll come up with the exact same thing that we had when we did it using the node voltage method, right? So let's go ahead. And, okay, I1, notice they're all positive, first of all. So we've chosen the proper direction for all of the currents. I4, 4, okay. So let's see here. I might as well write this in. So this is I3, so this would be 3.2 amps. This one right here would be 2 amps. And this along the top branch would be 0.75. Good so far. All right. Well, okay, so if we take the difference between I2 and I1, okay, that's the current flowing through that 40 ohm resistor. We'll say I2 minus I1. Well, that is 2 minus 3/4, so that's 1.25. And notice I've written I2 as the first current. That means that I am going in the same direction as I2, which would be down. Okay. Same thing, the current, excuse me, that 40 looks terrible. The current through the 50 ohm resistor, I will write it as I3 minus I2. And okay, that would give us 1.2 amps. Again, in the direction of I3, going down through that resistor. So this would be 1.25. This will be 1.2. And similarly, if I want the 100 ohm resistor, 100, I'll say I4 minus I3, which gives us 0.8 of an amp. And we're done. Now go ahead, take a look at your notes, but you'll find that those are the exact same currents that we had when we applied the node voltage method. Pretty nice. Multiple ways to skin a cat. Okay, well, let's go ahead and do a second example that we know the answer to. So we've already dealt with this circuit. There we go. Take a minute, apply mesh current, and get the current flowing through all the branches. You got it? Good, good, good. Okay. So again, as we develop our intuition, we see that it becomes a little bit easier to identify our meshes. So I'll go ahead and I'll go clockwise on this one. Call that mesh 3. And hopefully you see as we're moving through, you start finding yourself doing these a little bit faster just because practice. Okay. So we'll go ahead. We'll write down the equation for mesh 1. Well, I'll start here. I've got a jump of 10 volts. So I've got a jump of 10. Then a drop across our 10 ohm resistor. I1 minus I3. Keep going. Oh, I've got a drop across my 40 ohm resistor. And then I'm back at my starting spot. Same thing. Let's keep going. 2. Well, I'll start here and I get a drop across my 40 ohm resistor. So I'll call that I2 minus I1. Keep walking, keep walking. Oh, okay. Another drop across my 20 ohm. So that's I2 minus I3. Keep walking, keep walking. Oh, now I have a jump. I have a jump of 20. And notice that I delta corresponds with I1. So I'll call that I1. And I'm back to my starting spot. So again, we have a dependent source in here. Well, the third one. Okay. Well, I'll start here. I have a drop of 30. Keep walking, keep walking. I have the drop across the 20 ohm resistor. I3 minus I2. And I have my drop across my 10 ohm resistor. I3 minus I1. And that gets me back to 0. Right? And we run. Right? All of the physics is done. Now we just have to apply our linear algebra to get our final answers. Okay? So let's go ahead. I will use the first column as I1. The second column is I2. The third column is I3. Now go ahead. Always good to double check, Greg. I mean, there are a ton of fat finger typos all over the place. But what I have is that I1, I2, and I3 equal, I've got negative 3.2, negative 3.8, and negative 1.8 amps. In other words, I have chosen the wrong direction for all three of these currents. C'est la vie. Not to worry, that's fine. Let's go ahead and get stuff like the current through the 20 ohm resistor. I'll go ahead and do it as I2 minus I3, which will equal negative 3.8 minus a negative 1.8. Right? Don't forget those double negatives. So I get something that says that it's 2 amps negative. So rather than flowing in the direction of I2, it's going in the opposite direction. So it's something like 2 amps in this direction to the left. Well, how about I10? We'll do this one as I3 minus I1. And so we get a negative 1.8 minus a negative 3.2. Okay, well, that's just 1.4 amps. And notice this time it's positive because it's in the direction of I3. So I go like this, and this is 1.4 amps. Awesome. How about 40? How about I40 through the 40 ohm resistor? Well, you can kind of see what's going to happen here. Let's do I1 minus I4. Excuse me, I1 minus I2. Boy, it really wants to put that extra bar in there. There we go. And so we get negative 3.2, just plus 3.8. So I get the 0.6 amps. Again, running in the direction of I1. That's the one that we chose to go first. So we have the 0.6 amps going down. And again, if we check against our node voltage method, we should find that we're getting the same answers. Nice. You know, like, right? I mean, at this point, it's just a matter of getting practice with all of it. Let me give you one more. Because there was a special situation in the node voltage situations where if we had two essential nodes separated only by a potential source, we could form something called a supernode. It's just a very special circumstance. You can probably imagine what would happen if we have two adjacent meshes separated by a current supply. We call it a supermesh. Let me go ahead and give you the example. I'll walk you through this one, and you can see in the equations how the supermesh is formed. So consider this circuit for a moment. And I am going to go ahead and I'll call this mesh 1, call this mesh 2, and I'll call this top one mesh 3. And because I have a current supply, I'll go ahead and just call this potential difference across this current supply. I'll just call it V question mark. Okay. Now let's go ahead. Let's go ahead and write down our equations for mesh 1, 2, and 3. Go ahead. Got it? Good. Okay, so let's go through. Starting with mesh 1, I have a 10-volt jump. And then notice I have another 10-volt jump due to V question mark. Not 10 volts, excuse me. A jump due to V question mark. Then I have a drop across the 2 ohm resistor. So I1 minus I2. And I'm back to my starting spot. Mesh 2. I have a drop across the 2 ohm resistor. I have a drop across the second 2 ohm resistor. And then finally, I have a jump of 6 volts. Last one, mesh 3. I have a drop across the 2 ohm resistor at the top of the circuit. I have a drop across the 2 ohm resistor shared with mesh 2. And then here's the special one. I have a drop of V question mark. And then I'm back at the beginning. And now hopefully you kind of see where it's going to happen. I'm going to take my equation from 3, and substitute into equation 1 to get rid of v question mark. Okay. Let's go ahead and write down that equation. I have 10, okay, and I'll keep this piece. So I have 10 and then v question mark. Well, I move this one to the other side. And so I have 10 minus 2i3 minus 2i3 minus i2. And then I still have this leftover piece, minus 2i1 minus i2. And that whole rigmarole is equal to 0. Now let's look at this equation for a second. This equation that we have written down. Do you see that that equation I could have arrived at had I started here and I go through my 10-volt supply, and instead of doing my small loop here, I keep going and I go through this 2 ohm resistor at the top, this 2 ohm resistor, that 2 ohm resistor back to the bottom. So it's almost like I could have just completely ignored that current supply, if you will. Right? I kind of skipped over that, pretended that those two meshes, 1 and 3, were combined. Okay. This is what we call a super mesh. And again, the situation happens when you have two adjacent meshes separated by only a current supply. You don't have to remember it. If you're comfortable with applying the mesh current rules, the super mesh will automatically fall out. So we have that equation. We still have equation 2, negative 2i1, i2 minus i1, minus 2i2 minus i3, plus 6 equals 0. We still have that equation. And you notice, though, that we still have to get a third equation. We have three unknowns. And the third equation is going to come from the current source. We notice that if we take I1 minus I3, so I'm thinking about, I'll get rid of that. I'm thinking about this branch right here. I1 minus I3 must be equal to the value of the current supply. So there's my third equation. I'll use the current supply to give me my relationship between I1 and I2, the difference, I1 and I3, the difference between those two. So there's my third equation. I1 minus I3 equals 0. Go ahead. So if we set up our linear algebra again, we should get something like I1, I2, I3 is equal to, I have 7, 6, and 5 amps respectively. Right? Notice they're all positive, so we happen to choose the proper directions. And so I guess the only other thing is finding the current between this 2 ohm resistor and that 2 ohm resistor. Well, this top one that I've got highlighted, it's 3, I'll say 2 minus 3. So we get something like it's 1 amp going to the right. And similarly, if we do 1 minus 2, we get 1 amp going down. So at this point, I'll leave it to you. Okay. It's important, even I know that I don't ask a lot of homework questions, but you need to start practicing this. Okay. So if you don't feel comfortable with the homework questions, or if you're still kind of unsure, then you need to go to the back of the chapter and just start cranking through problems. Okay. And of course, again, the whole point of this is to minimize the number of equations that you have to solve simultaneously, number one, and then using, for example, differences in the mesh currents to get branch currents. Okay. So you're still doing 5 equations and subbing and solving. It's just a matter of what equations you're using. Are they simple equations like the difference in currents, or are they equations like KVL and KCL where you do it all in one go? Okay. So keep practicing that. Okay. Keep practicing. That's all I have for right now. I thank you for your attention. We'll continue on with a couple of extra analysis techniques. And yeah, keep on keeping on. Thanks for your attention. I'll see you next time.